One of the things I want to add to the application is the ability to give the user some feedback when it's doing network I/O. Right? It's actually important to let the user know when you're doing a fetch, give them some type of visual feedback that you're fetching something on the network. That way, if it does take 10 seconds on a really bad wireless data network, the user doesn't freak out and think the app's not working. They'll actually see some kind of visual feedback that, hey, the app is still loading data, just be patient. And it turns out on iOS devices, there's lots of ways we can do this, but one of the things Apple has done is they have what's called the network activity indicator that runs up on the status bar. And you maybe have seen this if you're an Apple user. A lot of apps, when they're loading, you'll see a little tiny rotating little gear up there on the status bar that goes on whenever an app is fetching network. And our app is not doing that right now. It's just kind of, as I scroll around here, it's basically, we're not seeing any of that. So it turns out we're on Wi-Fi and it's very fast, and so loading here is almost instantaneous. But we know that's not going to be true if we're going down the highway or out and about on wireless data. Sometimes that loading can take a lot longer. So we want to add the capability for the user to get that kind of feedback. And so what we're going to do here is add some code to our app delegate. So the app delegate is a singleton. And we haven't talked much about app delegate yet, but there are certain things your app delegates to this class. And there's things like when we go into the background, if we want to do some processing, that kind of stuff gets handled by our app delegate. So there's one app delegate instance per application. So it makes sense to put some global code there that whenever we do network fetches, we want to turn on this activity indicator, and whenever we're all done with all network I/O, we want to turn that thing off. Okay, and it makes sense we need a singleton to do that because it's kind of global control over that global thing. So I'm going to modify my app delegate to do this this activity thing, and so I'm going to go into my delegate here, and I'm going to add a property. So this is the app delegate right here, and it got generated when I created my project. I'm going to add a property to this guy, and it's just going to be a counter. So I'll call it count, and it's going to be an optional wrapping an int. So I'm just going to keep an integer count of the number of fetches. You see, it's not enough to simply turn on the indicator when I'm fetching and turn it off again when I'm done fetching, because I can have multiple HTTP fetches going at the same time, right? So when the user swipes up really quick and a whole 10 or 11 new tracks show up, I might have up to 10 different image fetches that all go off at the same time. So it's not enough to simply turn it on and off in my code in a real linear way. I need to kind of keep some state data here about how many fetches are we doing right now across the whole app. And that's what this counter is going to be. So every time we do a network access, we're going to turn up this counter. Every time we're done, we're going to turn it down. It's real simple. The very first time we turn it up, we're going to turn this thing on. Actually, we can just turn it on every time we increment. But when we decrement, we're going to look, and if it's 0, that means that was the last one, and we can turn it off again. All right? So I'm going to add that single property to count, and then I'm going to add some extra methods on here. I'm going to add a function or a method, and I'm call this one increment network activity. And I'm going to increment my counter, and then I'm going to, oops, that was an optional, so I need to explicitly unwrap it. So I increment my counter, and then I'm going to turn that network activity indicator on. Well, that network activity indicator is shared by all apps. There isn't a different one for every screen because it's up on the status bar, right? So it's more of a system level component here. And so we can get at that thing, and this is just something you end up looking up in the documentation to figure out how to do. So there's a class out there with a static method. It's called UI application, and it has a static method, shared application, which returns us an instance to the UI application. So this is a singleton as well. And this thing happens to have a property called network activity indicator visible. And if I set that to true, it's going to turn that thing on and it's going to start spinning. All right, so just turning that property on, and this global property here is going to make iOS start spinning that guy. And then we write a decrement. Let me just add some spaces here so we can get this more up. We're going to add a decrement that does kind of the analogous. So we're first going to decrement. Well, we don't want to first decrement. We want to check if self-dec count is greater than 0, then we'll decrement. So we don't want to go this should never happen, but we'll be defensive. Okay, so if that is true, we'll do that. And then if this thing is equal to 0, then we need to stop that indicator. So we can say if self.count, and I got to unwrap on these guys. I keep forgetting to do that. So if this thing is equal to 0, and bear in mind there, that's an explicit unwrap operator. That's not saying not equal to 0, right? It's an unwrap. And then if that was the case, then we're going to do the opposite of that top one. So we're going to say UI application dot shared application dot network activity indicator equals false. And just for good measure, if I got totally screwed up, I'd like a reset on here. So I'm just going to say reset network activity indicator. And so if I canceled all I/O, this would just be a fast and easy way to simply say set this guy to 0 and then turn off that okay. Now that adds the code to the class, and now we need to go back and strategically insert calls to these methods whenever we start doing network access, and whenever we successfully complete one, we're going to do the decrement. So we're going to go back. The very first place we did a network fetch was in our master view controller. In view.did_load, we kicked off this fetch over here to basically fetch the content for our top tracks. So the very first thing I really need to do here is increment. So keep in mind the task actually starts down here. So right here I'm just going to call this method, and that was implemented on the delegate. And it turns out if I can get that UI application reference, I can ask it for its delegate. All right, so I'll do a very similar thing to what we did before. I'll say UI application, shared application, and then I can say delegate, and I'm going to explicitly unwrap this thing as app delegate because that's the type. And once I've done that, I can call increment network activity. So that will start the thing spinning, and then when this fetch completes, I need to turn that off. Where do I put that? So I'm going to need to do a decrement. Any ideas? Roland?
Yeah,
Exactly, exactly. So I'm going to go down here and simply do the same thing. I'll say UI application, shared application, delegate as app delegate decrement. Okay, so that will give me what I need when the JSON's being fetched, but I also have the image fetching, right? So if we go down to the code for the image fetching, and we look at what we've done here, this is obviously where it starts, but I don't really have control over what happens after that fetch completes, right? That's buried down inside that Objective-C code that I stole from GitHub. Borrowed, stole, whatever, right? And so I could kind of turn it on here, but I still got to go out to that other class and modify it, and it's Objective-C. All right. So I need to do something a little bit different. What I'm going to do is I'm going to go in and change the Objective-C code to call these two APIs in Swift. Not only is that cleaner, so I'm going to modify this third-party code that I got and put all that code under the hood there. Okay. Not only is this cleaner, but it gives me the opportunity to show you kind of Objective-C calling Swift, which is slightly different. But it's real easy. So to make that app delegate visible to my Objective-C code, there's one thing you need to do. We need to put this attribute. So where we've defined this class, we need to put this annotation on there that simply says Objective-C. So if we put that on there, that basically makes it visible on the Objective-C. So this is Swift class, putting the Objective-C on the front right before the class means I can now call it. It's going to be visible for me over in my Objective-C code. So then I'll go back into that Objective-C code, and it turns out in the implementation of this category, I can call that, and I've pre-written these, and this is Objective-C syntax. Okay, let me first talk to what's going on here. So we haven't really talked about Objective-C, but here is the code. So this right here turns it on. And you're probably already glad we switched to Swift, right, when you see this? But it's really not that bad. So this is just a C-style typecast right here. And it's saying, hey, the result of this expression, which starts at that square bracket and ends on the second square bracket, okay? So in Objective-C, when we call methods on objects, the syntax is open square bracket, so left square bracket, object reference, in a class, if it's a static method, it would be the class name, space, the message or method name, followed by parameters. So what we're doing here is we're calling the class level method shared application on UI application. Okay, so that's the syntax, that's this piece right here. Then once we get that, we're calling the delegate. We're accessing the delegate property on this thing. That's this piece right here. Okay. That now gives me an object of type appDelegate. And appDelegate, remember, was defined in my Swift code, and this typecast here in front of that says, hey, this is not just a void star, this is actually of type appDelegate. And then once I've done that, that gives me the visibility to this method right here, increment activity, network activity. And the same thing follows down here. So I'm just using standard Objective-C syntax for invoking the same thing. So if you paste that line and put it next to the Swift line, and you understand that calling a method in Objective-C is, open square bracket, object reference, space, method name, parameters. There are no parameters in this case, close bracket. If you know that concept, you should be able to look back and forth and see a one-for-one correspondence there. Now let's see if it works. No breakpoints. All right, I saw this before. Why is this a problem? Oh yes, thank you. It's nil. So I need to. So when this method here gets called when my application loads for the first time. So I can simply say self.count equal 0. And that assigns this guy to a wrapped number. Now it will work. Okay, watch up in the upper left. Did you see that? It was very fast, wasn't it? It's kind of hard to see. Let's spin. Okay, when you spin, did you see those? Okay. Now, when you're testing your app on your desktop, you have a really fast Wi-Fi connection that your emulator's piggybacking on top of. And sometimes there are certain features like this one where you can't really see, is it working or not? And so if you install the right developer tools, so under Xcode, if you go to Open Tool, More Developer Tools, there is a tool. Let me just do that. You have to log in. What was my password here? Oh, it knows. Okay. This hardware I/O tools for Xcode. If you grab that and install it, you'll end up on your system preferences. And if you hook the device on, it'll actually show up on your iPhone developer preferences on your actual device. But if we're using a simulator, we'll go into our system preferences, and you'll see down here at the bottom, I've got this thing called Network Link Conditioner. And if I double click that, where'd it go? Okay, there it is. And what I can do here is I can specify, act like you got a very bad network. All right? And now when I run my program, yep, thank you. Pair programming. Now when I run my program, it's like I'm running out in the sticks. And now we can actually see that thing is working. See my activity? So this is very bad. So if you live where I live, this is how your networks work.
Yeah.
No, you just...
You can make a free developer
yes.
account and download it.
Yes. Yeah. So you do have to sign in as a developer, but you don't have to. You can have the free developer account. You don't have to pay the $99 to get this. Okay, there. Everything finally settled down, and you notice that that network indicator went off again.